We've learned the language of probability: certain, impossible. We've got a sense of the likely, unlikely. We've got a sense of the probability scale in terms of zero, using numbers. So zero means something is impossible, one means it's certain to happen, and any number in between, so fraction and decimal between 0 and 1, gives you a degree of how likely or unlikely, so closer to zero, unlikely an event is. Well, let's look at actually calculating probabilities in a bit more detail. The idea of working out the probability of a single event occurring. And so, for example, if you have a dice, that's the example put forth here. I have a dice, I can roll it, I can get 1, 2, 3, 4, a 5, or a 6 on a dice. And if it's a fair dice, that word fair or unbiased is really important, and that means that the outcomes are equally likely. So the chance of getting, if it's 6 numbers, the chance of getting a 1, there's only 1 out of 6 is 1/6. The chance of getting a 2, there's only 1 2 on the dice, so the chance of getting a 2 is 1/6. That's the big idea. The probability of an event, the probability of getting the outcome you want, is the number of successful outcomes, so the number of ways of getting what you want, over the total number of outcomes. So in the case of the dice, you can get a 1, 2, 3, 4, 5, or a 6. So the total number of outcomes, 6. The number of successful outcomes, if I want a 5, there's only 1 5, so 1 on 6. This is the big idea we'll be working with. And actually, we're going to start, am I right? We're going to start with the example of the fair dice and dive into it deeper. So you can get a really sense of how this works. Now, I always believe that we all come in with different abilities, and it's quite possible you might be watching this and saying, "Oh, really? I know how to do this," and that's fine. In that case, why not? Here's the pen. Use your pen. You can't use mine. Let's be serious about this, but you get the idea. Here's a pen. You should have your date, title, learning objective down already. Task 25 as your reference, and do the question. Don't. I've talked about it. Maybe you have a sense of it, or you're an expert at this already. You think, and it's some quick revision. Doesn't hurt. Practice makes perfect. Go on, do the question. Answer A, B, C, D, and E. Pause and go on with it. I'm going to start working through it slowly and hopefully in a conversational tone. And if this is not something you're confident with, as a result of going through this example and a couple others, hopefully you gain a lot of confidence. That's the idea. So we'll stick with this idea. The number of ways of obtaining an outcome, or the number of successful outcomes, that's the way it was framed on the initial slide, over the total number of outcomes. And it's all about rolling a fair dice. Each number is equally likely. And what are the numbers? I'll put them at the top here. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Those are the numbers on a dice. So 6 numbers. What does that mean? Well, it means that when you do this question, I would expect that your denominator in all of your answers would be a 6, at least to start off with. We will get into simplifying fractions after. So, because for all of these options, it's the same fair dice that is being rolled, so the total number of outcomes is going to be 6. And what we need to focus on is what's going to be the top number of your fraction, the number of ways of getting a particular outcome. So, if I put for the first one, I have a 6 as my denominator. My answer is always going to be between 0 and 1. That's really important because 1 is certain in probability. Can't get bigger than 1. And the number of ways of obtaining the outcome. So I want a 5. How many different ways can I get a 5? Well, there's only one way to get a 5, so the chance of getting a 5 is 1 out of 6. That's the idea we're trying to build. Part B, getting a 3. How many different outcomes do I have on the dice? Again, the denominator is a 6. My top number for my fraction, I want a 3. How many 3s? That's the event getting a particular outcome, getting a 3. There's only 1 3, so the chance of getting a 6 is also 3, is also 1/6. Now it comes into this idea of an even number. What's the chance of getting an even number? And we need to remember, what are even numbers? Even numbers are the numbers in the... That's right, even numbers are in the numbers within the 2 times table. So in this particular case, I could circle, I'll highlight it. The numbers in the 2 times tables, it's 2, 4, and 6. So the ways to get what I want, the different number of ways to get an even number, there are 3 different ways to get an even number. The total number of outcomes, well, there's 6 numbers on the dice, so 3 out of 6. Generally, in probabilities, there is no need to simplify your fraction. This question says, what's the probability? It's 3 out of 6. It did not say to write your answer as a fraction or a decimal or a percentage. You could have done either of them. And it doesn't go further and say give your answer in the simplest form. You just want to, so 3 out of 6 is a valid answer. That said, for many people, they would want to or automatically think to simplify the fraction. And 3 on 6, fraction work is, simplifying fractions is not the focus now, but divide by 3, divide by 3. If you divide them by the same number, you can simplify your fraction, you'll get a half. But it's important for me to note that in the context of probability, I don't think I've ever seen a GCSE question which asks you to simplify, but I have seen questions where perhaps being able to simplify came in handy. I have seen it, in fairness, but in general it's not necessary, okay? But we want to be able to simplify fractions. The next question, part D, and perhaps I need to consider my numbers a bit more, so let's go to a different slide. For part D, you have your answers for A, B, and C. So for part D, I'll use this slide, and let's put those numbers again. The numbers. When I roll a fair dice, what are the numbers I can get? I can get a 1, 2, 3, 4, a 5, or a 6. And we're looking at part D, and we want a multiple of 3. And you can see what's coming out here. First, and this is one of the challenges that comes up with probability questions. It's also used to test your knowledge and understanding of other concepts in mathematics. So, even number. Do you know what an even number is? That could have easily been a question about odd numbers. Now, it's about this idea of a multiple. What is a multiple of 3? So, you know what it is, because if you don't know what you're looking for, you can't count how many of them there are. Multiple of 3 is exactly, it's the number in the 3 times tables. That's what a multiple of 3 is. So how many numbers are in 3 times tables on a dice? Well, there's 3. 3's in the 3 times tables. 3 times 1 is 3. And also 6. 3 2's are 6. Those are the 2 multiples of 3, or the 2 numbers in the 3 times tables. If I then think, well, number of ways I can get the outcome. There's 2 different ways to get a multiple of 3. I can get a 3 or a 6. And there are 6 numbers in total on the dice. What I want, the number of ways I can get what I want, divided by, or fraction bar, the number of total number of options available. 2 on 6, that's the answer. Can I simplify 2 on 6? Well, the way to answer that is 6, I'll give you another question of saying the same thing. Is 6 a multiple of 2? Yes, it is. So we can divide both numbers by 2, and we can get 1/3. So the chance of getting, the probability of getting a multiple of 3 when you roll a fair dice, an unbiased dice, fair unbiased, what does it mean again? Yes, it means that all the outcomes are equally likely. It's 1/3. And finally, a number less than 6. A number less than 6. Now, how many numbers are less than 6 on a dice? 1, 2, 3, 4, 5. Is 6 less than 6? Language is important. Were you going to count to 6? Have you got caught with that? Note that it said number less than 6. It didn't say less than or equal to. Number less than 6. There are 1, 2, 3, 4, 5 numbers less than 6. So what I want, there's 5 ways to get at what I want. 5 numbers less than 6. And let me just scroll this up to fit. I think I'm running out of a bit of space. I'll just rub this off so we have a bit of space. The chance of getting a multiple of 3, we said, was 2 on 6, which is equal to 1 on 3. When we simplify it, a number less than 6, there are 5 numbers less than 6, and it's 5 out of 6. The probability of getting number less than 6, 5 out of 6. Those are your answers for this example. I should have said example 2. Wasn't it example 2? Yes, it was. No, example one, actually. Don't worry, I changed things around. It was originally the third example, but it now became the first. Okay, so that's the idea there that you're looking for. Um, so you get a sense probability and how we can work it out. Shall we do another example? We'll do another example together, or maybe you did this one on your own and you marked it and you're smiling and you want to do the dance. You know me, I like, and you get something right, you got to feel good and say yeah, 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 yeah. And forgive the voice. It's a bit every time the temperature changes a bit, I start to get a bit husky. So please forgive that. Having a drink would probably help. Having a coffee, not just a drink of coffee. Hey, oh, let me be careful. Right, let's not go there. Just my coffee. Just my coffee. Right. Number task 25. Task 25. To be able to calculate a symbol probability of a single event. We're continuing, and we have a second example here. This time about a packet of sweets. That's what we're looking at. A packet of sweets. So you why not read it? Have a go. Pause the video. Have a go. I know I call it examples, but I just so think you want to get stuck in and try for yourself. Once you have a little bit of an idea, just get stuck and see what happens. The most you can do is make a mistake and be wrong. And mistakes are brilliant teachers. You learn so much from it. Okay. I'm gonna do it now. The packets. There's 18 red. There's 12 green and there's 10 yellow. Is there any other color? No information about that. We talk about a sweet being taken random out of the packet and what's the probability that it's red. Well, the first thing I need is this idea. Well, how many sweets are in that pack? How many sweets are in the pack? And you should agree with me that there are 40 because I'm working out the total, and the total is 18 plus 12, and 18 and 12 is 30. And if I add another 10, I'm going to get 40. So all these questions, the denominator is going to be 40. That's what we should be thinking about. And I'll move on to another page just to make it easier to read. You should have paused and had a go if you're going to have a go. So red, we had 18, so total, I'll just write it again. Total is 18 plus 12 plus 10, which gives you 40. Just testing, can I look at the camera, smile, and write at the same time? Let's see if I can do it for red. So the denominator is going to be 40. No, I can't do it. I gotta look at the screen. A denominator is going to be 40 because there's 40 sweets in total. And then I want how many red? How many red are there? There's 18, so the chance of me getting a red will be 18 out of 40. Can I simplify it? Yes. Does the question ask me to simplify it? No, but just as practice, I will do it anyway. Both are even numbers. I can divide by 2s, and I get 9 on 20. Now, 2 might not have been the highest common factor in terms of this idea of simplifying fractions. But when I look at 9 on 20, there's no common factors. There's no number that goes into 9 and 20. When I say no number, we do not consider 1. Because dividing by 1, you'll divide forever and ever and ever. You're not changing the value, are you? So 9 on 20 is what we have there. Now, part B. Whoa, what are they on about? They said not green. Now, how many packets? What's the chance? How many packets? How many? Not packets. How many sweets are in the pack? How many sweets are in the pack is going to be my denominator. Remember, the total number of outcomes, the total number of choices that I have, is the bottom number of the fraction, and it's 40 again. Now, not green. Well, if it's not green, what color is it going to be? And that's right, and I can put that up here. We're thinking about I got all those colors. It can be red, it can be green, or it can be nah, don't do yellow. Nah, the yellow is not gonna happen. I'm just gonna put that yellow. Or it can be yellow. Okay, I don't have yellow as my I don't have a yellow pen option, and I'm not gonna dig for a yellow pen option. Okay, no, I'm not doing it. Let's stick with that's yellow. Okay, that's yellow. Red, green, and yellow. It is yellow. Can't you see the lovely light yellow color it is? Work with me here. Come on. Right. It's not green. We had. Let's look at this. If I think of this as like a mini table, 12 were green, 18 are red, and 10 are yellow. So not green has to be the yellow, those 10, and also the red, those 18. And 10 and 18 give me 28. So I'm going to put, what does red, now I was thinking about colors. The red and yellow make green. When you mix red and yellow, what do you get? Or do you get blue? No, not blue. I'm not sure. I need to check that. No, red and yellow is going to be orange, isn't it? If I mix red and yellow, I'm going to get orange. I'm going to check that on Google at some point. But let's finish this question. 28. 28 is going to be my numerator because not green means red or yellow. That's another one. We're going to come up talking about that language, the word or, later on, but that's the idea. If it's not green, it has to be red or yellow because those are all the different options of sweets in this packet. Okay, and that's 28 on 40. Again, I do not have to simplify. You'll see me banging on about that. If you want to leave your answer as 28 over 40 in an exam situation, you will get top marks, but I see it as an opportunity to practice simplifying fractions as well. They're even numbers, so we can divide both of them by 2. The voice, wow, it's bad, but the show has to go on. Divide by 2, that gives me 14 on 20. Can I divide by 2 again? Yes, divide by 2, I get 7 on 10. So 7 on 10 will be the answer in its simplest form. You could have, instead of dividing by 2 and divided by 2, I could have divided by, what's the highest common factor? What's the biggest number that goes into 28 on 40? And that's what you always should be looking at. The biggest number, similar to the work we've been doing, or you should have done with factorizing, or I shouldn't say this because everybody's sequence would be different, but if you've done work on factorizing algebraic expressions, then this idea of looking for the highest common factor is something you should be familiar with. And it's the same technique for fractions. Well, I got to take care of the voice, don't I? The biggest number that goes into 28 and 40 is 4. So you could have gone with that. Right, so we have to find a chance of getting red. We have is 9 on 20. 18 on 40, I think, is easier to think about it. Not green, red or yellow on 40. The last one we had to think about, let's just get that in there, was green or yellow. Note, previously not green. Let me just put it down. When we said not green, what we realized was that was red or yellow. So red or yellow is what not green meant. Now we want green or yellow. We can do, we just visualize it again. The red, we have the red, we have the green, and I have my beautiful yellow. Yeah, don't start me on that yellow again. We talked about that already, didn't we? 18 is how much red we have. 12 is how much green. And we have 10 yellow, that beautiful yellow color that I'm displaying there, okay? Gotta have some fun, a bit of a laugh. Make yourself smile, smile. I'm doing mathematics. What better can I be doing with my time? I know, I feel that. Do you feel the same way? I do hope you feel the same way. Okay, green or yellow? Green or yellow? Green or yellow? There's 12, 10, 22. To get a green or a yellow, there's 22 options to choose from. So the numerator, the number of successful outcomes is 22. The number of outcomes in total is 40. What am I saying? 40. So the probability of getting green or yellow is 22 on 40. Can we simplify? Yes. Do we have to? No. So smile. You can move on if this was just your answer. I'm going to divide by 2 because they're both even numbers. I'm going to get 11 on 20, and I'll stop because 11 and 20 have no common factor. So that is your answer to the next, to part C. And we've now looked at the dice and even probability of getting an even number, a multiple of 3, and that sort of thing. We've looked at this situation where we have, let's say, sweets in a bag, and what's the chance of getting one color or the other. And we've looked at critically how the word or, and you can see Where when we have or, what it means is to add the chance, add the number of greens to the number of yellows. So or, you're starting to build this idea. Hopefully now, when you see the word or in probability, it means that you need to add to your tally of how many ways you can get the particular outcome. Okay, so addition. The or rule, we're going to talk about that later, is to add. So just think about that there. Add. Should we do another example? I do have another example set up for this, but I'm sort of thinking that that is potentially enough to get you going with this. So I'm going to skip the other example, or what I'm actually going to do, I'm going to change the example into a question, more formally a question. So the next one, this was, so I'll bring it up. But I'm not going to do it in as much, talk through it as much as I did the previous ones. Read this question, have a go at answering it, and I will quickly give you solutions with some commentary, but I want you to do this question on your own. Pause, have a go. Example 3 is now practice question 0. I'm going to have to call it 0 because you'll have a practice question 1. So practice question 0. P0. Okay, can you do this question? Less from me, more from you now. Can you do this question, please? Thank you very much. Right, you had your moment. You pause the video and you're doing the question. You're doing it on paper and you're writing down enough information to make this useful for you in the future as a revision resource. So, pack of cards, 52. You know, I'll actually, can I? Yeah, no, I can't scroll down to do this one. I won't have space. But yeah, let's just make sure you're writing down. Just, you don't have to write down the question, full question or first statement. Just pack of cards, 52, and then probability of getting red. And the way you can do it, and we'll talk about this, we'll start using it a bit more, but for A, you can just put PR. That's the notation for probability. R will know red. Probability red, or better yet, actually I think it's not, because put P red, A P red, and work it out. What's the probability of getting a red card? For the queen, P queen. What's the probability of getting a queen, and so on and so forth. So you put 52 cards, playing cards, P red, you work it out. B P queen, and you do your calculations, so you have a written record. Don't just go writing probabilities, please. And that, that's, so you're doing that. And let me make some space. I'll start doing it now. You should have paused then. You pause and you're doing it. Good stuff. Right, let me begin my turn. You had your turn, my turn now. P red, probability of getting a red card. Now this question does depend on your knowledge of cards. I hope you're if you're, come on, ask somebody at home. If you're at home, you are at home, ask somebody at home. They can help. How many cards? Well, cards, the 52 cards. Let's just do the breakdown, and let me make sure I don't block it with the image of my lovely face that goes up in the corner there. You should be seeing my face up in the corner there. I like showing my face. Yeah. There are cards. Cards are broken down into 4 categories. You have diamonds, hearts, spades, and clubs. Now, I've put the different colors because the diamonds and the hearts are reds, and the spades and the clubs are black. And getting each color, each type of, each group of card is equally likely. If it's 52 playing cards, that means that getting a diamond, there's 13 diamonds, there's 13 hearts, there are 13 spades, and there are 13 clubs. Okay, that's the idea. So probability of getting a red card is 26. There's 26 red cards divided by, making my fraction, 26 on, there's 52 cards in the deck, 26 on 52. And yes, if you simplify that, it would be a half. So you have a 50% chance of getting a red card if you pick a card randomly from a deck of cards. For part B, a queen. There's a queen of diamonds, there's a queen of hearts, there's a queen of spades, there's a queen of clubs. 1, 2, 3, 4. Each suite of cards, that's the word I was saying, group and all sorts of, I forgot, I can't remember the last time I played a card game, to be honest, but it's a suite. Yeah, there's diamonds, the hearts, it's a suite. Yeah, they call them suites. Right. And that is suite, S-U-I-T-E, I believe. If I'm wrong, please somebody correct me, but I think that's the suite that we're talking about. Definitely we're not talking about suites as S-W-E-E-T. We're not, that's not what we're dealing with. A suite, the diamond suite, I believe that's the way we spell suite. I'm veering into literacy. Do I take the literacy box? Have I done that right? Ooh, I hope so. I hope so. All right, feedback is a gift. If I had done anything wrong, please say comment and challenge anything. Not because I'm the teacher, that means I'm right. A queen of diamonds, queen of hearts, queen of spades, queen of clubs. That's 4 queens. 4 is what I want. So not a queen. What I was telling you is what you'll write is probability of getting a queen. So you'll put a P and queen in brackets. It will be 4 on 52. All our fractions will have 52 as our denominator initially. You can simplify that. If you simplify it, you will get 1 on 13, a 1 on 13 chance, because we can divide by 4, divide by 4. So that's the idea there for part B. Let's move on to the other. There's 3 more. So actually, did I do that too quick? Let me leave that there. Pause one moment. You have a chance to pause it. Right, let's move on. Now, a red ace. Remember, it's diamonds, hearts, spades, clubs. Okay? There's an ace in each suite. If I want a red ace, there's only going to be 1, 2 red aces. Should put it in red. Give me that. Red ace deserves some respect. So there's 2 red aces, and the full pack has 52 cards, so 2 on 52, which if you simplify, you will get 1 on 26. Divide by 2, divide by 2. And then the 7 of hearts. How many, in a deck of cards, how many 7 of hearts do you have? Exactly. There's only 1 of them. There's 4 7s, but only 1 7 of hearts. So 1 on 52. 1 on 52 for D. And let us finish off the very, very last one we had to do for this one, an even number. Woo! That requires some work. You can do that one. Is there a 1 in a deck of cards? Does it actually matter? No, it doesn't. You can get a 2, you can get a 4, you can get a 6, you can get an 8, you can get a 10 in each suite. So in each suite, let's put this down, each, S-U-I-T, each suite, you have a 2, 4, 6, 8, 10. Is there an 11 in cards? Sorry, why do I want 11? I don't even, what is up with me? Is there 12? Is there 12? Is there 14? No, there's no 12, there's no 14. You got the numbers up to 10, and then the face cards. That's what we call it. Yeah, face cards. The jack, the queen, the king. Yeah, the ace. Ace is a face card. Oh, I'm digging myself in a hole, aren't I? You know, I clearly need to re-educate myself in cards. But 2, 4, 6, 8, 10. Those are the options for even numbers, and you're a bit forgiven. That's one of the reasons I was wondering if I should do what is now P0, is because your knowledge of it does rely on your knowledge of a deck of cards, which clearly you can see I'm a bit shaky on. I'm not, but I think I'm right. I'm right. Okay, 2, 4, 6, 8, 10. Those are the numbers in each suite. So there's 5 in the diamonds. Remember, there's the diamonds. There's the, what is it? Diamonds, the hearts, and then the spades and the clubs. Each of them have 5 even numbers. 5, 10, 15, 20. And I so put that near my face. I have to, yeah, well, don't worry. We'll sort that out. So an even number, there's 20 even numbers. There's 52 cards. The chance of pulling an even number is 20 on 52. Both of these are even numbers, and because they're even numbers, I can divide by 2, divide by 2. That will give me 10 on 26. So 10 on 26, which I can divide by 2, divide by 2 again, which will give me 5 on 13. So 20 on 52, and if you decide to simplify, 5 on 13 is what will be your answer. And that's the end of probability single events question number 0. I now have, this is such an important topic. There are, I think it's about 6 questions. I have 6 or 7 questions you're going to do. Because of the size of the screen, it's going to come up 1, maybe 2 questions at a time. You'll pause, you'll have a go, I'll give you the answer, and we'll just run through that cycle to get through this. Okay, so let's get going with the remaining questions. P1, first question up. You're getting down sufficient information in your book to make it useful for revision. Off you go to do these. Thank you very much. And you pause, and you've had your go. And now it's for me to give the answers. And I will, let's just see what should happen for the first one. It would have been 3 on 6, which you can simplify to a half. For the 2, it's 1 on 6. For the multiple of 3, and just to remind you, because we're building from the numbers, your options were 1. What? That should have been green. It should have been green. You're not, whoa, should have been green. Did I make a record? 1, 2, 3, 4, 5, 6. So all your denominators for all of them could have started off as being 6 and then simplifying. Multiples of 3, 3 and 6. So that is 2 on 6, which is a third. A number less than 5, there's 4 of them. So for D, 4 on 6, which will give you 2/3 when you simplify. A number greater than 4, there's 2 of them, so 2 on 6, which will give you a third. And then finally, a 3 or a number less than 3. Rather interesting language. A 3 or a number less than 3, there's 3 on 6, which will give you a half as your final answer. So your final answers: 6 1/6, a third, 2/3, a third, 1/2, or all the answers in 6. If you did not simplify, you're spot on. You're still going to get all the marks because the question did not ask you to simplify your answers. Let's move on to the next one. Number whoa, that's not showing. Number 2 and number 3, here you are. There are 2 questions. Pause. You have your go. You've already had your go because you paused and you tried the question and you've put enough information to make it useful in your book. And now I will provide you the answers reasonably quickly because I've gotten enough detail, I think, for you to make some headway on this. If it is that you do have an issue, of course, and you disagree with an answer, just get in touch with a teacher. That's the extra help. You're not just totally, it's not just all about the videos, post a comment, etc. And it's a two-way street. Yeah, there are people looking at this stuff and your responses. So it's all good. Right, 6 and 14 give. So how many sweets do I have in total? I had 20 sweets in total, of which 6 are red. So the chance of getting red is 6 on 20, which you can simplify to be 3 on 10. Then a blue sweet. How many sweets are there in total? Number of outcomes, 20. That's your denominator for your fraction. There's 14 blue. And so 14 out of 20, 14/20ths is the chance of getting blue, which is the same as 7/10. So that's the answers you should have there. Probability always between 0 and 1. Toss a fair coin. That means each option is equally likely. Chance to get a tail. You either get a head or you get a tail, so there's 2 options. The tail is one of them. The chance of getting a tail on a fair coin is a half. What's the chance of getting a head on a fair coin? Spot on, half as well. So those are your answers for 2 and 3. Let's do some more. Wow, 4 and 5, off you go. Let me I can get a bit more space on this screen. Yeah, that looks a bit better. You have question 4 and 5 to do. Pause. Off you go. You've done it already from the screen. Now I'm going to give you the answers. Red. We're looking at red. Red counters. There are actually what we need is what's our total going to be? What's our total before we simplify? There's 9 red. There's 21 blue. That's 30 counters in total. So my denominator for each of my answers I could think is going to be 30. I'll even put that there. And red, there's 9 red, so 9 out of 30. Blue, there's 21 blue, 21 out of 30. Green, did they say anything about green in the answer? No, 0 out of 30. Now, we need to deal with, and you saw there was hesitation here. You don't write that. Oh, I thought I changed my color. Got it now. You don't write 0 on 30. If it's impossible, you write 0. That is your answer, not 0 on 30. In general, 0 on 30 is 0, but it's expected that you would recognize, in a case like that, it's expected to recognize that it's impossible, and you would represent it using its simplified version. You'll just write 0. In an exam, if you write 0 on 30, expect to be penalized. You probably won't get the mark. Could you have simplified these fractions? Yes, you could divide by 3 and get 3/10. You can divide by 3 and get 7/10. Not necessary, but those answers are acceptable. Even if you put 30, I can go a bit further. If you put 30%, you would get the full marks. If you put 0.3, you'll get the full marks. Similarly, 70% or 0.7, all are acceptable answers. For the cases of 0, something is impossible, we expect to see 0 and only 0. Similarly, for the case of something that's certain, we expect you to put 1 as the answer, not in this case 30 out of 30. You know, it is the same thing, but we want to see that you understand certain 1, impossible 0. And if I'm trying to doubt myself, if I said somewhere before then that 0 is certain, I'm sorry, the brain goes a bit funny sometimes. 0 is impossible, 1 is certain. Okay, just that's my disclaimer. Question number 5. If you didn't do it, you have the chance to do it now. If it wasn't as clear as possible, you have a chance to do that now. Pause, have a go. You've paused. You've already done it. I'm going to do question number 5 now. Probability. First of all, the first thing you want to do, it's a spinner, how many, and they said you're looking for that language. They said everything is equally likely. I have 1, 2, 3, 4, 5, 6, 7, 8 outcomes, 8 choices. So the probability of a 1, probability of 1, I'm doing A, the probability of getting a 1 would be 1, 2, 3, 4, 4 out of 8, which is equal to a half. The probability of getting oh damn, B is over here, and shall we work in blue? Blue is a better color. The probability of getting a 2, so probability of 2, we can write that as our notation. There's 2 2s, so 2 out of 8. There's 8 choices, and that is a quarter if we simplified. For C, the probability of getting a 3, there is 1 3, so that's 1 on 8. For D, the chance of getting a 4, so probability 4 you could have written. There's only 1 4, so that is 1 out of 8 is the chance again. And then to wrap up those, I'm going to have to scroll down a bit. So for A, B, C, D, E, for E, the chance of getting a 5, the probability of getting a 5. I look on that spinner, I spin around, there ain't no 5. Chance of getting a 5 is 0. It's impossible. And for F, the probability less than, a number less than 6. I'm just going to use the less than symbol, less than 6. It looked better the first time. Probability of getting a number less than 6. I look around the spin, I go, and all of the numbers are less than 6. The chance of getting a number less than 6 is certain. It's 1. Now, you cannot write the word certain or impossible. The expectation at this stage in this context is that you would give numeric answers 0 and 1. 0 for impossible, 1 for certain, not writing the words. That's what we would expect. There might be flexibility in an exam for that one, but the expectation will be to use the numbers. Okay, right. Let us move on. Let's do some more. Should we? Shall we? Now for question 6 and 7, and you'll perhaps notice a slight change in the way the questions are structured. Do you really get what we're doing, and can you apply that knowledge in a different context, in slightly different contexts now. Let's see. That's what we want to explain here. So I'll give some more explanations, but off you go based on your knowledge of probabilities so far. What are your answers to 6 and 7? You do your working. Go for it. Pause. You've had a go. You've had your go. Yes, you have had your go, including number 7. Yes, you have done it. You haven't just looked at it and said, I didn't know what to do. You haven't done that. You ready? Okay, let's talk about it. For You'll recall all probabilities are about being equally likely. So the probability of getting a 3 on this spinner, what you'll see is that the visually you can see that the outcomes 1 and 2 not the same. You have a better chance of getting the 3 if you draw a nice little line down there. You'll realize that actually a better way to represent this, to really clarify the diagram, is that now I've made it's actually, if I split the circle into quarters, that the chance of getting a 3 I have 2 it's actually a half, 2 out of 4. So if I just visualize it as 4 parts, I prefer that. You don't have to, but I think think of looking at it as 2 out of 4, which is equal to a half. Now you might be thinking, well, hang on, what you did that for? You could have just looked at it and seen it's a half. But I like adding in that detail just to make it clear that it's about equally likely events. I thought there was something in it. I hope it didn't confuse you, but yeah, the chance of getting a 3 is a half. Okay, that's what's expected on that question. Now number 7, and if you hadn't had a chance to do number 7, you can do so now. They said the probability is 3 on 5. The way of looking at that, almost this is the art of being a teacher. You're just thinking, how do I present this so that everybody's going to understand that the answer is going to be 4? Yeah, the answer is going to be 4. Did you have 4? If you have 4, do the dance. If you don't have 4, let's talk about why. If the probability of red is 3 on 5, that means that you have, and I should put it in red. Come on, let's do the color thing right. Come on, teacher. Show you got some style here. If the chance of getting red is 3 on 5, what it's telling you is that there's 3 red, and then for how to write it, for every 5. Because remember, the bottom number is the total. So that's 3 red for every 5 balls in total. Out of 5 balls, 3 have to be red. That's what 3/5 is telling me. And if that's the case, and I only have red balls and some white balls, that means when I have the 3 red, the other bits, and I don't have white, but it has to be 2 white. I'll just put 2W there. And that means if I have another 3 red, then I need to have another 2 white. And now if I add up, I can see I'm getting the 6 red. Stick with the colors, sir. 6 red. And if I have 6 red, I will have to have 4. I have to have 4 white. Okay, 6 red and 4 white will give me 10 balls in the bag, which question is not asking us about how many balls that we have in total. It wants to know how much white, but what we wanted is we need to get that 6 red, and it's just for every 5 there's 3 red, 2 white, another 3 red, another 2 white. In total you have 6 red, which is what we're told, 6 red. So 6 red for 4 white. So how many white balls are in the bag? There are 4 white balls in the bag. And I hope that explanation makes sense, because I was looking, when I looked at this question, I included it. It goes into the world of ratio, sharing in a given ratio for every 3 red, 2 white, 3 red, 2 white, and making that big link between ratio and fraction. So it's a probability question, but it's an interesting one. Hopefully that makes sense. If that makes sense, you got to start thinking, yeah, I'm top grade stuff is where you're heading for. If it doesn't make sense, you're still having success, but that we can take it to the other level. This is a really big idea, I think, that this question captures. So I hope it makes sense. And if you had it right, you did the dance. If you didn't get it right, hopefully this approach makes sense. And next time you see one of these, you can have success in it as well. Let's to last question, number 8. Let's look at things slightly differently. Look at down there. What do you see? The fractions are gone. Are you ready for this? Read the question. A fair amount of reading. Read the question, answer the question, and then we'll do part B, and we'll build it from there. Okay, right. You paused. You had to go. You did it. This question, two things are introduced. You're reminding you, making explicit that you can represent a probability as a decimal. It doesn't always have to be a fraction. And then the other big bit about it that it brings home an idea we haven't talked about, but is very, very important, is that all the probabilities must always sum to 1. All the different outcomes, I must always, when I add up all my probabilities, I should always get 1. Because it's either, once we have all the possible outcomes, it's either it's available, in this case, to being used, it's available but not being used, or it's broken down. There's no other option. And if we have this option or this outcome or the other, remember we talked earlier about the idea of or, meaning to add. The sum of all your probabilities needs to lead to what is certain, and just think about that. And certain is represented by the number 1. So if this outcome doesn't happen, then it has to be the other one or the other one. They all have to be one of these outcomes. The chance of one of these happening is certain. We don't know which one, but the chance of one of them happening is certain, which means the chance of one of them happening is 1. So what do I have in total so far? And if that makes sense to you now, but hopefully it has to make sense to you first to move forward on some more complicated stuff. But how do you find a missing number? If you weren't aware or clear on this idea that it has to add up to 1, if that didn't come up, you have a chance now with this fact. What's the missing probability? Pause, you work it out. Good stuff. And what you should have done. What did you do? Did you get 0.88 as your answer? Do the dance. Yeah, because what we're doing, 0.09 plus 0.03, the probabilities that we have already, give us 0.12. So what's left is 1, which is 1.00, take away 0.12, which will give you, I'm asking myself, what do I add? I don't really like this, what they call it, the column method. It's painful. I'll just show you this way. I'm just going to think, if I start, I'm not even going to think about decimals. I'm thinking 12 to 100. And this is the way I visualize this. So if I start at 12, what do I add to get to 20? I need to add 8. And then to get to 100, I need to add 80. So the difference between, and I add that up, the gap between 100 and 12 is 88. So the gap between 0.12 and 1.00 is 0.88. That's the way I would think about it. If it is, you were doing the canceling out method. Borrow 1, put 1, borrow 1, put 1. 10 take away 2 is 8. 9 take away 1 is 8. 0 take away 0 is 0. Yeah, I've moved on from, this is what I learned in school. Back in my day, it's probably what you learned in school as well. Column method. There are a lot more practical methods that allow for faster mental work as well. Either way, regardless of method, 0.88, all your probabilities have to add up to 1. That's the big idea we're bringing home here. And let's finish off this. One more to do to finish off task 25, to finish off this lesson. Let's bring home this idea that all the probabilities have to add up to 1. Here's part B. Here's part B of this question. Whoa, okay, we got it now. There's your part B of the question. Read, pause, take your time, read it, fill in the missing numbers. This is a top question, level 5 to 7. That was students who were on the way to going on to pass their GCSE maths exam. And 1995, that's wow, 1995 had this bad boy. How do you deal with that? Off you go. Pause. You paused. You had a go. Let's see if you know what you know. Uh, yeah, I tried to do something. Okay, right. At 1,000 hours, see, these two is these all these probability. This is one circumstance, one situation, and this is another situation. So you got to think about things separately. And at 1,000 hours, when I'm doing a trial, at 1,000 hours, if it failed at 0.07, then it's still working, has to add up to 0.93. Okay? At 2,000 hours, if it's failed, there's much higher likely of failing, 0.57, then the chance it's still working is 0.43. Because the probabilities have to add up to 1. What's happening at 1,000 hours has to add up to 1. What's happening at 2,000 hours has to add up to 1. Those are your answers. Sum of all the probabilities in a particular situation adds up to 1. Those are your answers. Single events now. Sorted. Yeah, sorted. Probability of a single event. We're going to expand on this topic. We're going to look at, this is all theory. So far what we've done, what about experimental probability? What happens when we do experiments? That's what we're going to look at in task 26.